Hi class, so this question is question number 25 on the chapter 13 Sapling homework, and it's a little bit confusing, and so I just wanted to run through it really quickly. So here we are asked to consider a two-step reaction mechanism. So step 1 and step 2, this would be the reaction mechanism for this overall reaction where 2A plus B turns into D, and we're asked to find the rate law for the overall reaction. Now, we're told that step 2 is a slow step. So if step 2 is a slow step, then we might say, well, the rate is going to equal K times the concentration of C times the concentration of A. And I know that this is going to be my, rate law because this is an elementary reaction. These are single step reactions, so I can write my rate law directly from the actual chemical equation. And since this is my slow step, this is going to be the rate law that really governs this overall reaction. Now, the problem with this is that in our overall reaction, C, the concentration of C, does not show up. C is what we would call an intermediate. It's formed during the course of the reaction, but then it's consumed during that same course of reaction. So C goes away essentially. So it's not really satisfying or correct to have C, our intermediate, in our overall reaction rate law. So what we need to do is we need to consider step 1, and the fact that it's an equilibrium, it's a fast equilibrium, is going to give us some information about how we can sort of rearrange things or what have you to figure out our rate law for the overall reaction just in terms of A and B concentrations. So at equilibrium, so if we want to consider the equilibrium, which is step 1, we know that at equilibrium, the rate of the forward reaction is going to equal the rate of the reverse reaction. So we might say that the rate of the forward reaction is going to be K forward times the concentration of A times the concentration of B. And that's going to equal the rate of the reverse reaction. So R reverse, which will equal K reverse times the concentration of C. So when I say K reverse times the concentration of C, that's from the point of view of C going back to form A and B, and the forward reaction A and B reacting to go forward to form C. So at equilibrium, these two rates, they will be equal to each other. That's the definition of equilibrium. So now what I want to do is I want to take sort of this information here and rearrange things so that I have just concentration of C by itself. So I can see that that will equal concentration of C equals the K forward times the concentration of A times the concentration of B, all divided by K reverse. So just sort of dividing K reverse. And now I can substitute all of this information into my previously determined rate law. And I can rewrite all of this as R equals, so now it's going to be some K from this reaction times K forward over K reverse times the concentration of A times the concentration of B times the concentration of A again, right? So K forward, K reverse, AB, and then K here, concentration of A over here. I can rewrite this R equals K prime, or sort of just taking all of this into consideration, I can just write K times the concentration of A squared over the concentration of B. Here I'm writing K prime just to indicate that it's a different K value, that I've taken all of these K values all together. But normally we just say that that's going to be our K value times the concentration of A squared times the concentration of B. So a little bit of a different wrinkle on a problem, and I just wanted to give a quick explanation of that.